Today, we are formalizing this idea of what we call the empirical rule. Now, some of you are wondering, hey, didn't we do this already? And we did touch on it. I explained this at the beginning of this whole topic, that this is one topic where you have the same concept as mathematics standards. So if you've been noticing that they're doing the same kind of thing, then you'll be able to help them out with all their work, hopefully, in this topic. So when we are looking at this, we can consider them as functions, right? But the empirical rule is a kind of shortcut way of doing this. And in a formula sheet, if you have a look over to the right side over here, here we go. So you can see that actually on your formula sheet, they give you the percentages that are there, right? So you know that between, if this is our mean, right, so 0, right, then between one standard deviation to the left and one standard deviation to the right, it contains 68% of the data. So between this region, we contain 68%. And we've already had a bit of a conversation about that, but now we're just going to be formalizing that, right? And as you expect, the more standard deviations you go out, the more data it's going to capture, so 95% or the 99.7% and so on and so forth, okay? So before we move on though, I just wanted to show you that, you can find regions not within one standard deviation. We can do stuff like, if this is our normal distribution over here. Yeah, right. So we will look at z-scores next lesson, even though we've kind of already touched on it formally. But you can move this slider to whichever region you want, right? So here you've got 34.1. That seems wrong. Let's see if we can get this. It should be. Oh, okay. Oh, that looks like they've rounded a little bit. Hey, 68.3%. So this is the issue with the table as well, right? With that rule that we're using, it's just easier to give you that as 68% rather than 68.3, which apparently it is. I don't know if this is wrong or they're wrong.
Maybe Joy's wrong.
Maybe Joy is wrong. Well, also, why is this one? When I go to 0, that one's 34.1. Half of that apparently. Oh yeah, that makes sense. Yeah, that was so. Yeah, okay. Half of that. And then if we go to 2, what was 2 meant to be again? Let's have a look. 95. The hardest bit is getting the finger right. Oh yeah, 95.4. That's not too bad. Let's see if the -3 to 3 is accurate. The hardest part is actually getting. Come on, I got it. What do we get? All right, that one's actually right. Yeah, awesome, cool. So you can see, this is the idea behind normal distributions. We can capture a certain amount of area underneath the curve in that respect, okay? So that's the empirical rule in a nutshell, right?